You've seen it on TV 100 times, right? The forensic genius who just knows the answer with one magical clue. But the reality? Well, it's way less about magic and way more about science. It's about a strict scientific playbook that every single investigator follows. So let's open that playbook and see what the real rules of the game are.
So if it's not some magic trick, how in the world do they do it? How do real investigators walk onto a scene that's pure chaos and get the physical evidence, the silent stuff, to tell its story? Well, it's definitely not a lucky guess.
It's all because they follow that playbook. It's a set of really powerful, unbreakable scientific laws that turn simple objects into hard evidence. And that evidence, well, that's what leads to answers. These rules are the absolute foundation of forensic science.
Okay, so the playbook starts with 3 foundational principles. You can think of these as the rules that cover the what and the where of the evidence, like what is it and how did it even get here?
First up, we've got the law of individuality. Now, the official definition, yeah, it sounds a little academic, but the idea behind it is incredibly simple and honestly mind-blowing. Every single thing is unique. Nothing, and I mean nothing, is a perfect 100% copy of anything else.
And this is so important because that uniqueness is the entire basis for identification. It's the reason why even identical twins have different fingerprints. It's why the way you write, the specific pressure you use with a pen is yours alone, and it's why those tiny microscopic scratches a gun leaves on a bullet are like its own unforgeable signature. This law is what lets an expert say, with confidence, this bullet came from that specific gun.
Next up is probably the most famous principle in all of forensics. You've probably heard it before. It was summed up perfectly by the father of forensic science himself, Dr. Edmond Locard, who said, "Every contact leaves a trace." This is officially known as Locard's exchange principle, or the law of exchange. And what it means is that any time 2 things touch, they swap a tiny piece of themselves. It's unavoidable. A criminal cannot enter a room without leaving something behind, and they can't leave without taking something with them. It's a physical law, whether you can see the evidence with your naked eye or not.
And you can see how this plays out in the real world all the time. Fibers from a sweater end up on a suspect's jacket. Mud from a specific field gets stuck on their shoes. Invisible gunshot residue coats the hand that fired a weapon. And in a stubble, an attacker's skin cells get trapped right under the victim's fingernails. It's this mutual swap that makes trace evidence so incredibly powerful.
The third foundational law is the law of comparison, and its logic is just beautifully simple. You have to compare apples to apples. You can't match a fingerprint to a boot print and expect to get a result that makes any sense. And this table really shows you the heart of the process. On one side, you have your question sample. That's the mystery evidence from the crime scene. On the other side, you have the known sample. That's a control you take from a suspect or a tool. So a latent print from the scene gets compared to a suspect's known fingerprint. A bullet from the scene is compared to one they test fire from a suspect's gun. This side-by-side comparison is what forensic science is all about. Okay, so those first 3 laws, they're all about finding and comparing the evidence. But once you have a potential match, what does it actually mean? That's where the next part of the playbook comes in. These next 3 principles are all about the how and when of the analysis. Now, this one is absolutely critical to understand, the law of probability. And it's a huge difference from what you see on TV. Real science almost never deals in 100% certainty. Instead, forensic conclusions are all about likelihood. The question isn't, is this the guy? It's, what's the statistical probability that this evidence belongs to this person versus anyone else on the planet? But don't you dare mistake probability for weakness. Just look at this number. When a DNA expert gets on the stand and says that the chance of a random person matching the sample is 1 in a billion, well, that statistical statement becomes some of the most powerful evidence you could ever present in a courtroom. So yeah, understanding this difference is key. Probability gives a conclusion its scientific weight, its statistical muscle. On the other hand, claiming you have absolute certainty, that's not just unscientific, it can be really dangerous in the pursuit of justice. It's all about being precise and honest about what the science is telling you. Next up is the law of analysis, which honestly is just a rule of pure pragmatism. To put it simply, you can only work with what you've got. The amount of evidence you find and what condition it's in directly controls what tests you can run and how much info you can possibly get out of it. But this is where it gets really cool. Technology is constantly pushing the boundaries of this law.
I mean, decades ago, a tiny or degraded sample would have been totally useless. But today, with amazing techniques, a forensic scientist can take a single skin cell, or just one hair with a root, and generate a full DNA profile. It's incredible.
And our final rule in the playbook is the law of progressive change. This law is all about a fundamental truth of the universe. Time changes everything. Evidence is not static, it's not frozen. A crime scene, a human body, a drop of blood, they are all constantly changing from the second an event happens.
And investigators can actually use this to their advantage. This timeline here is a perfect example. By observing the predictable stages of rigor mortis, that's the stiffening of muscles after death, a medical examiner can actually work backwards to estimate the time of death. Time itself becomes a clue.
So we've gone through the whole 6-part playbook, but at the end of the day, why does it matter so much? Why are these 6 specific laws the beating heart of every single criminal investigation? Well, it's because when you put them all together, they form the absolute bedrock of a fair justice system. They give us a rigorous, objective, scientific framework that makes sure evidence is handled with total integrity, from the moment it's found, through analysis, all the way to a courtroom. These rules are what lift forensics from being just a guess into a real, hard science that can stand up to any challenge. Which kind of leaves us with one final thought. As our technology gets more and more powerful, to the point where we can analyze almost unimaginably small traces of evidence, which one of these foundational rules do you think becomes the most important for us to remember? To make sure that justice is always, always guided by sound science.